Yes, we have completed this all. Okay. Bismillahirrahmanirrahim. Today we will discuss about DC circuits, but parallel circuits, right? DC parallel circuits. So DC parallel circuits are basically named as your current divider. Is that screen visible to you?
Yes, sir.
They are called your current divider. So when there are, yani, these are current dividers. So actually, current divider circuits are those in which there are multiple paths for the current to flow through. So if we have multiple paths for the current to flow through, then the current would flow. For example, current I is there, I total is there in the branch, in the main stem and in the main circuit. Then it will be divided into two, three, four parts, whatever the number of parts you are providing it in the way. So that will be divided accordingly. For example, here I have provided three paths to the current. One is through R1, the second one is from R2, and third one is from R3. So current will be divided equally, sorry, not equally, accordingly, that it is your I1, then I2 and I3. So both of all these currents are basically combined together again at this junction. This point is also named as junction. So at this junction the current is combined together. At this junction current is basically dispersed or divided. So junction is that point where either the current is distributed or current is combined together. So total current in the main stem is again same as that of this one, but in all these branches the current would always be less. But the main significance or main feature of this parallel circuits is they have equal potential difference. All these resistors have equal amount of potential difference. So when they have equal amount of potential difference, it means we can say that current is in divided in such a way. Dekho, there are only three features: V, I, and R. So if V is same, R, if R is different, then I would be different. That's it. Okay. So here the current is divided in such a way that if you combine all the currents together, you will get the total current. So I1 plus I2 plus I3 will be equals to I. Got it? So this is the main equation that will be basically helping, or that will be defining the current. So I can simply say that when you are going to add the resistor in parallel, what will happen? The resistance will decrease. What will happen to the resistance? Resistance will decrease. So just remember one thing, that R equivalent decreases when you are going to connect the resistors in parallel. But when we were connecting the resistors in series, so क्या हो रहा था? Resistance was increasing overall. Is it? ऐसे ही हो रहा था ना? So R will be decreased in such a way that equivalent resistance will be less than the smallest value of in the circuit. Smallest value in the circuit. So the equation that will be used for your R equivalent here, that is R1, 1 upon R1 is equal to 1 upon R2, sorry, 1 upon R1 plus 1 upon R2 plus 1 upon R3. And this equation is asked for derivation. Okay, this equation is, you have to derive this equation basically. So 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon Rn. So अगर आप लोग देखो, so this all is basically in such a way that if there are uh, two resistors, then it R equivalent will be only 1 upon R equivalent is equals to R1, 1 upon R1 plus 1 upon R2. But you will, when you will solve it, that is simply you have solved it. And when you will solve it, it would become R1 into R2. ये LCM लिया मैंने basically. I have taken LCM, and when I have taken LCM, it is R1 into R2, and above it, it would be R1 plus R2. So overall, that is your R equivalent is product over product of resistances divided by sum of resistance. So that is basically product over sum formula. Usually we use that one for two resistors, only for two resistors. In case of identical resistors, the equivalent resistance in parallel combination will be number, yani resistance of any single resistor divided by number of resistors. Okay, any single resistors divided by number of resistors. So that will give you the total number, sorry, R equivalent. For example, you have yeah, in series n was multiplied, yani number of resistors was multiplied. For example, I have four resistors of each 100 ohm in series, so their total resistance in series will be 400. But if I have four resistors in parallel, each is of 100 ohm, so it would be 100 divided by 4, so it would give you 25 ohm. Is this clear? ये clear है दोनों को? Afan, sorry, Mohsin and Yahya.
Clear.
Okay, then the battery current increases when more parallel resistors. This is very, very, very important point. There are so many questions asked, which would be clear from this point only. That when you are going to connect more resistors in series, sorry, more resistors in parallel, what happens? Your total current increases, na? So total current is basically your battery current. So what is your total current? Total current is your battery current. So battery current increases, total current increases when the resistors are connected in parallel with each other, right? That there is another main point, that R equivalent, current is inversely proportional to resistance. So least resistor will have the largest current flowing through that. You have to keep all that point in your mind. Here there are so many resistors I put in, all in different combinations. ठीक है, तो first of all I just marked, this is your point x, this is your point y. So what is the equivalent resistance between these 2 points x and y, where all the resistors are identical? Are you getting it?
Yes.
So this is single resistor R. These are three in parallel. These are one, two, three, four, five in parallel. So first of all, I will solve these combinations of parallel. So these combinations of parallel means here all are identical and three are total. So it would be R by 3. Here all are identical and total number is 5. So it is R by 5. So now all these are in series with each other. So R by 1 plus R by 2 plus R by 5 would be added together, and you will get the R equivalent is equal to 23 by 15 ohm, or 23 by 15 R. Is it clear?
Yes.
Okay. Now, here are some examples I have figured out, and then we will practice some of the questions basically. Just check this one out. This is a question, and in that question, the question is, the diagram shows a network of three resistors. Two resistors marked uh, are identical. Okay, two resistors which are marked R, they are identical. Uh, the other resistor has the resistance of 5 ohm. That resistor has the resistance of 5 ohm. These two are of 5, sorry, R and R. The resistance between Y and Z is found to be 2.5 ohm. The resistance between Y and Z, yani between this point and this point, is found to be how much? 2.5 ohm. अब आप देखो, I can simply say, I can simply redraw that diagram. Check this one out. What did I do? I just marked this point Y and I marked this point Z, right? This point as Z. So I just redraw that all. The game is wait. Sorry. Okay, this is Y. About the question is, what is the resistance between X and Y? What is the resistance between X and Y? It means that what is the resistance between these 2 points? Which are those 2 points? These 2 points. ठीक है जी? यानी resistance across this. So we have redraw that equation. देखो, this is a complicated question, not an easy question. That's why I have selected some of the questions which are really horrible for the students. So I just divided the circuit into some parts. They go, first of all, R equivalent between Y and Z is 2.5. R equivalent between Y and Z is how much? 2.5. It is given to you. What does it mean? 2.5 and this, yani, this R and R, both resistors are in series, and collectively they are parallel with 5 ohm resistor. So this R and R collectively in parallel in series, yani, with each other they are in series, and collectively they are parallel to this 5 ohm resistor, right? So it means R and R becomes 2R. Is it? Are you getting my point? And here it is 5 ohm. So total resistance, because now they are in parallel, so parallel, you will write the formula of parallel resistors of 2. So that is why I told you that for two parallel resistors, resistance is R1 into R2 divided by R1 plus R2. So R equivalent is equal to R1 into R2 divided by R1 plus R2. So 2 times R into 5 divided by 2R plus 5. So what will be the total number? That will be 10R by 2R plus 5. Just see that 2R plus 5 is written as it is. 5 to the 10R plus. So just put all the value here. Just see this data. 2.5 is the R equivalent because that is given to you in the question. Is 10R divided by 2R plus. So from here I will calculate R. Simple. What will I do? I will calculate R. So the R is 2.5 ohm. What is R? R is 2.5 ohm. Now there is a problem. The problem is you have to find the total resistance between X and Y. So here 5 ohm and 2.5 they are in series. Here is that graph. Check this one out. 5 ohm and 2.5 they are in series, and this 2.5 is parallel to that. So 2.5 plus 5, that is 7.5, and 7.5 is parallel with 2.5. So that is why I made 2.5 into 7.5 divided by 2.5 plus 7.5, and 1.9 ohm is the total answer. Okay? Is this clear? This is a complicated question. So I believe that you people would be able to handle these type of questions when once you will be practice, yani in practice, then it would be very clear to you. Okay, this is one of the question. I have just bypassed one. This one I will solve that for you. Yes, there are some resistors. Check check this question. A battery is connected to a network of 6 resistors as shown in the figure. Okay? I will discuss these all yani, while practicing the stuff. This question is just a past paper question, and that's it. Uh, these all areas are those areas in which you are supposed to have some sort of, mm, series and parallel practice over. Yeah, series and parallel discussion over. Now we will practice the questions for series and parallel. You people are requested to take your papers or your